that, I'll hand over to our first section and to Terry Perles to talk about the vanadium market. Terry, over to you.
Very good. Thank you, Mikhail and John, for hosting this event, and just reiterating what two gentlemen have said. Vanatech really is here to create a forum for us to share information and pool resources to improve the opportunity to utilize vanadium in various applications. So we do appreciate all of the support from the people out there of this organization. I'm going to talk a little bit about the vanadium market, supply and demand side. And the purpose of this talk is really to try and understand where we're at from a production and consumption standpoint, what forecasts are out there that are going to impact this market in the coming years, and how we see the industry moving forward to address those issues. So we can go ahead, John. We're going to talk about vanadium consumption. This data that we're looking at right here is from a research report published by Guidehouse Insights several months ago, looking at the utilization of VRFBs in energy storage, grid level energy storage applications. And you can see here the forecast that they're showing is very significant growth in the number of megawatt hours of installed capacity annually for VRFBs. And we can directly translate this data into a forecast for demand for vanadium in VRFBs. So if we go to the next slide, we'll see that this data can be rolled up, and we see this very interesting growth cycle for vanadium in flow batteries based on this this projection. You'll note that this forecast shows that by 2030, the total amount of vanadium going into flow batteries approaching 130,000 metric tons of V. And just for the sake of scale, today the global market for vanadium is around 115,000 metric tons of V. So we're more or less talking of a doubling of the demand for vanadium over the next 8 years as a result, primarily of the growth in VRFB demand. But that's not the only place where we'll see growth in the next 10 years. So if we go to the next slide, we'll see how we try and roll up the whole forecast. This chart is showing consumption of vanadium by country. It's important to understand that about 90% of the vanadium consumption today occurs in the steel industry, about 6 or 7% in the chemical industry, and 2 or 3% in the titanium alloy industry. In the titanium alloy industry, demand's been very weak the last few years as aerospace industry has suffered badly due to COVID. It is bouncing back right now, and looking forward, we'd expect demand from titanium industry to return to something like 5% of the total demand prior to the explosive potential growth here of vanadium in energy storage. But you can see that this chart basically looks at consumption by country, and then it overlays energy storage on top of that. It's really difficult to break down the energy storage projected demand by country. We just don't know where these batteries are going to be built. Obviously, a lot of them will be in China, but we just kind of lay this potential demand on top of the growing demand from the other applications. And you can see here by 2030, we're talking about something very close to 300,000 metric tons of V. John, going to the next slide, we can see that we break this demand down into a couple of different categories. Historically, in the steel industry, where most of the demand occurs, we see two variables driving growth in demand. One is just the number of tons of steel produced globally. And if we go back really to the 2000 through 2018 or so, we saw very explosive growth in global steel production. And that was the main contributor to growing vanadium consumption. As we get into 2010 and 11, we do see the specific consumption rate of vanadium in the steel industry. That is the kilos of V consumed per ton of steel produced increasing. And we expect that to continue as high-strength low alloy steels continue to replace relatively low strength carbon manganese steels. There's economic benefit through the entire supply chain for this substitution. And so although steel production probably isn't going to grow at astronomical rates in the coming years, we will see continuing growth in vanadium consumption from the growing specific consumption rate. And then, of course, we see the gray area in this chart, the massive growth in demand potential here from VRFB systems. Next slide, please. We'll go on to production of vanadium here now. And this is a chart that looks a lot like the last one. And here, what I've done is tried to put together a forecast for production of vanadium that will basically mirror the growth in consumption that these forecasts are showing. And this forecast is, one possible scenario for how we get to where we think we're going to need to be at 8 years. And what we do here is we look at first just the base production that occurred through 2020. The orange segment of this chart shows potential increased supply from existing producers, that is producers that are out there today. They have facilities built, mines, or other facilities to produce vanadium. They aren't either being fully utilized or are on standby at this point. So there's a significant amount of potential growth in vanadium production that we can see in the coming years from existing producers simply by more fully utilizing their existing capacity and the restart of some idle capacity out there. And then on top of that, we show what's really going to be required from new sources of production in the world to reach those goals. Next slide, please. And here, again, we try and look at production and break it down by country. Some interesting observations here. Obviously, you can see this forecast suggests production of vanadium will continue to grow in China, and that will be the major source of growth. But you also see Australia popping up here as a major supplier in the coming years. This forecast assumes that there will be a number of new primary projects showing up in Australia. And at the same time, you see somewhat smaller but still important new supply coming from the Middle East, and that's primarily secondary vanadium units that will come from recovering vanadium from residues coming out of the oil industry. Next slide, John. Here we try and look at the supply by source of raw material. There's really 3 major sources of raw material that support vanadium production globally today. The most important today is what we call co-product steel slag. This is a vanadium-bearing slag coming out of steel mills in China, and one in Russia and one in New Zealand. These steel mills use a vanadium-bearing magnetite to produce steel, and they will produce a co-product or a byproduct slag where the vanadium is concentrated. Typically, this material is 14 to 24% V2O5 content, and historically, this material supplies about 70% of the world's vanadium. The other sources of vanadium are primary mines. These are typically mines that are mining the same vanadium titanium magnetite, but there is no steel mill associated with those mills. They're extracting the vanadium. There's also a number of other primary mining operations that we forecast that will come online in addition to these magnetite-based operations, in particular stone coal-based production in China. We have a project potentially coming online in Kazakhstan with a multi-element ore, but by and large, the forecast that we're showing here shows growth in primary production coming from vanadium titanium magnetite deposits. And then the secondary materials we see growing as well. I think this is important because for various reasons, the opportunities to recover vanadium from residues coming out of the oil industry are growing. There is vanadium present in oil in various parts of the world. And when that oil either gets burned in a power station or goes through a refinery, the vanadium and typically nickel and any other trace metals will show up in some sort of residue or waste material coming out of those projects. And those waste materials are bought and sold for their vanadium content and processed for vanadium and or nickel extraction. There's been a significant change in International Maritime Organization rules regarding sulfur levels in bunker fuel that ocean-going vessels will burn. And as of a year ago, the sulfur level had went down by almost an order of magnitude. Historically, bunker fuel was the heavy bottoms coming out of the oil refineries, simply blended together and burned in ocean-going vessels. But with this new specification in place, all of those heavy residues now have to go over catalyst, and they need to be treated to remove sulfur. So what we're going to see in the coming years is these refineries that are now operating catalytic facilities to remove sulfur from the heavy bottoms. Eventually, those catalysts are going to be deactivated and need to either be recycled or disposed of. And we do see that those sources are going to contribute significantly to new production in the coming years. And important to note that it's a much shorter timeline to develop a secondary vanadium production facility to recover vanadium from these materials than it is to develop a new vanadium mine. So in the near term, we do expect to see some significant increase from those sources. And then later in this forecast, we see the vanadium primary mines coming online in a bigger way. John, next slide. If we look back in time and look at what's happened in terms of change in vanadium production year on year, you can see this this pattern. And we see years when vanadium production has increased, well above 15% a year, and we also see some years where vanadium production actually moved down from year on year. And if you do run an average on this data, I think it's going to tell you average growth rate's something about 7%. Next slide, John. Okay, now let's roll up production and consumption and kind of throw these two on the same chart. This is a little bit confusing maybe, but let's first just look at consumption. The purple line is the forecasted consumption that we saw before, which includes obviously a significant amount of vanadium going into VRFB batteries. The yellow line shows what we expect to see in terms of vanadium consumption if we presume there's
You still hearing Terry?
No, I don't hear him.
No, we
Don't
lost
hear
him.
him either.
I think we've lost Terry for a moment here. Let's see if we can get him back.
So as we were going through this and showing the scenario with two demand forecasts, one assuming that the guidehouse forecast for VRFB demand for vanadium comes to be, and the other, the lower limit is assuming no vanadium going into energy storage. And we see here that the guidehouse forecast will require some fairly significant new sources of production coming to market over the next several years. If we go to the next slide, in order to meet that projection, we can see what sort of annual growth in vanadium production this forecast is assuming. And if we look back in time, we see the average growth annually is something less than 10%, whereas looking forward, this forecast, if it comes true, is going to require vanadium production to increase at something above 10% a year for most of the balance of the decade here. And again, we can see times where that has happened in the past, and we would have to see the supply grow, at that 10% or above level for the next 7 or 8 years to meet that forecast. Next slide, John. I want to talk about the availability of vanadium because I've been asked the question a number of times, is there enough vanadium out there to rely on VRFB or some of these other technologies? And it's fundamentally the wrong question. There's plenty of vanadium in the ground, and the question really is, how fast can we get it out of the ground, and at what cost? If we look at resources in the ground, there's enough vanadium in the ground to continue with consumption at today's levels for more than 150 years. So there's no question about availability of vanadium in the ground. Next slide, please. This is just a snapshot of some potential future projects out there. These are a combination of vanadium titanium magnetite deposits and some other types of deposits. And the point here is just to show you what potentially could be out there. And if we kind of scroll through the next slides, John, what we see here is just a never-ending list of potential vanadium projects out there. And we can go on here a couple, and this is a map showing deposits of vanadium titanium magnetite as well as sandstone and shale-hosted vanadium deposits around the world. Next slide. And the next 5 or 6 slides here are just some data on potential vanadium projects out there. And the point here is just to demonstrate that again, the question of is there enough vanadium is fundamentally the wrong question. Which of these deposits come to market first is anybody's guess. But what we do need to see is some investment flowing into the vanadium space here to allow for some of these primary projects to take off. We're already seeing investment in some of the secondary projects by companies like AMG. And so again, this slide's going to show us, I think one of our previous speakers talked about the availability of vanadium versus other transition metal or battery metals. And we can see there's more vanadium in the Earth's crust than there is chrome or lithium or nickel or cobalt or copper. So again, just confirmation of the fact that there's plenty of vanadium out there. Next slide, John. And this is just some data looking at concentration of metals in the Earth's crust, and we see near the lower end of this this list, vanadium is the 22nd most abundant element in the Earth's crust. Next slide. And that at the end of the day, vanadium occurs in a number of different elements. It's has a relatively high content in the Earth's crust. It is the case that a lot of these deposits are relatively low grade, and so now you start talking about the economics of extraction of vanadium. But looking at the availability of vanadium, I think there's no question about the ability of the industry to supply a massive growth in vanadium content in the coming years. And go on here, in terms of electrolyte, this is just a slide from our company, US Vanadium, looking at various impurities in the electrolyte. When we start talking about electrolyte for VRFBs, we also have to address the quality issues. And every battery company has their own proprietary specifications. There is a fairly broad distribution of allowable levels of various impurities, but this is something that people need to be aware of as they start looking at vanadium electrolyte for VRFBs. And next slide, John. Just I'd be disappointed if I didn't give you a little bit of information about US Vanadium. We have spent some money to build a vanadium electrolyte facility at our Hot Springs, Arkansas vanadium plant. We can produce 4 million liters of electrolyte. We've delivered, I think, more than 700,000 liters at this point, and we're in the process of producing material for a number of customers out there negotiating ongoing offtake agreements. Next slide. This is just a snapshot of the 2 US Vanadium facilities. On the left is the Benton, Arkansas facility where we grind and roast various raw materials. And on the right is the hydrometallurgical facility in Hot Springs, Arkansas, where we extract vanadium from those various sources and produce very high purity vanadium oxides, as well as downstream chemicals, including electrolyte. So just summing up, it's really interesting to hear GJ and Brian talk. And as we go forward and we see the growth of VRFBs, and in addition, these other technologies requiring vanadium and energy storage, I would hope that people can recognize that there is adequate vanadium out there. There is a need for investment to start flowing this way, and production levels will start moving up to meet these forecasts, but it's certainly something that's doable. And that's it, John.
Great. Thank you, Terry. How appropriate or inappropriate that your presentation on energy storage got knocked out because of power. So
Yeah, exactly.
you're not at US Vanadium right now though. So